You do not require a match. You do not require a stove. You do not require a gas line, a propane tank, a butane canister, or any single piece of modern infrastructure to prepare a meal or purify your water. You require the sun, which is already present, and a shape. One specific geometric curve that human beings discovered how to utilize thousands of years ago, and that the modern world has almost entirely forgotten how to construct. I am going to demonstrate the build in about 90 seconds. Clay, foil, and a curve you can create with a piece of string. Then, I am going to show you something regarding the physics of that curve that is going to make you view every sunny day differently for the rest of your life. Stay with me. Here is the build. You need a shallow bowl roughly 18 inches across. Dig it from the earth and fire it from clay, or use a salvaged metal bowl as your form. The inside surface gets lined with whatever reflective material you have access to. Aluminum foil from any kitchen works. Flattened tin cans hammered smooth work. Mica, a naturally occurring mineral that splits into flat reflective sheets and has been pulled from the ground by hand for 10,000 years. It works better than either and costs nothing if you live near any granite or schist formation. You press the reflective surface smooth against the curve of the bowl. You mount the whole assembly so it tilts to face the sun. Then you find the focal point, the single spot in the air above the bowl where every reflected ray converges, and you put whatever you are cooking or whatever water vessel you are heating directly at that point. On a clear day at mid-latitude, a correctly shaped 18-inch reflector concentrates enough solar energy at the focal point to boil water in under 20 minutes and hold a cooking temperature above 150 degrees Celsius indefinitely. That is hot enough to cook rice, beans, eggs, fish, and flatbread. It is also nearly double the temperature required to pasteurize water. 65 degrees Celsius held for 6 minutes kills every waterborne pathogen that has ever made a human being sick. You are running at 150 plus. The sun is doing the sterilization. You are just pointing it correctly. That is the build. Now let me tell you where it comes from, because this history is one of the most extraordinary things I have encountered researching anything. In 212 BCE, the Roman fleet under Marcus Claudius Marcellus laid siege to the city of Syracuse on the coast of Sicily. The Romans were the most formidable military force on earth. Syracuse was a Greek city-state with one unusual advantage. It had Archimedes. What happened next has been debated by historians and physicists for over 2,000 years, and the debate itself tells you something important. Ancient sources, including Plutarch, Lucian, and Galen, all record the same account. Archimedes organized the defenders of Syracuse to position large polished bronze shields in a parabolic arrangement along the harbor wall. They angled those shields to concentrate reflected sunlight onto the sails and hulls of the approaching Roman ships. The ships caught fire. The Romans, according to multiple ancient accounts, broke the siege. A Greek mathematician, using mirrors and geometry in the same sun that was shining on everyone equally, stopped the most powerful army in the world. The experiment has been reproduced. In 1973, a Greek engineer named Ioannis Sakas lined up 70 men on a harbor front, each holding an oblong mirror the size of a standard sheet of copper. They aimed the reflected light at a wooden rowboat at a distance of 50 meters. The boat caught fire in under 3 minutes. In 2005, MIT students replicated the experiment with 127 one-foot square mirrors focused on a mock Roman vessel at a distance of 30 meters. Same result. Archimedes was not doing magic. He was doing geometry, parabolic geometry specifically, the mathematics of curves that collect parallel rays and redirect them all to a single point. And the same principle that set Roman ships on fire 2,000 years ago is sitting in your backyard right now waiting to cook your dinner. The Aztecs knew something adjacent to this, though their use of reflective minerals went in a different direction. Obsidian, volcanic glass formed when lava cools so rapidly that its molecules have no time to crystallize, was one of the most prized materials in Mesoamerica, not just as a cutting tool, but as a mirror. Aztec priests used large obsidian mirror discs in ritual and astronomical observation. More practically, obsidian blades were used to start fires through focused reflection in combination with dry tinder. The principle is the same one. A surface polished, smooth enough to reflect coherently, angled correctly toward the sun, concentrating energy at a point. The Aztecs, the Greeks, the Egyptians, who used polished electrum, a naturally occurring alloy of gold and silver, on the pyramidion caps of their obelisks to catch and scatter the first light of the sun each morning. Every ancient civilization that built at scale eventually found the same truth. The sun is the most powerful energy source available to a human being standing on the surface of this planet, and a polished, curved surface is the tool that makes it obedient. We stopped teaching this, not because it stopped working, but because it stopped being profitable to remember. The survival gear industry in this country sells solar cookers, parabolic ones, box ones, panel ones. They retail between $80 and $400. Some of them are genuinely well made. All of them are built on physics that has been in the public domain for 2 millennia, and that requires no manufactured components whatsoever to replicate. A parabolic curve pressed into clay costs nothing. The gap between what that knowledge is worth and what most people would pay for a branded version of it is the gap that the industry lives inside. You are not buying the physics when you buy the product. You are buying the packaging around the physics. The physics itself has always been free. Here is how the geometry actually works, because understanding this means you can build it anywhere from anything. A parabola is a curve with one defining property. Every point on the curve is equidistant from a fixed point called the focus and a fixed line called the directrix. What that means physically is that any ray arriving parallel to the axis of the parabola, any ray coming straight in, like sunlight from a distant source, will reflect off the curve and pass through the focus. Every ray, all of them, regardless of where on the curve they hit, they all converge at the same point. That is not an approximation. That is exact. It is why satellite dishes are parabolic. It is why radio telescopes are parabolic. It is why the reflectors behind car headlights are parabolic in reverse, sending rays out parallel instead of collecting them to a point. The geometry does not care what century you are in or what materials you use to make it. A parabola pressed into wet clay and lined with flattened tin cans focuses sunlight to a point with the same mathematical precision as a machined aluminum dish costing $400. To draw your parabola for the build, hammer a stake into the ground. Tie a string to it, hold a stick at the end of the string, and drag a curve in the dirt, keeping the string taut. That is a rough circle, not quite what you want, but shorten the string progressively as you move away from center, and you begin to approximate the parabolic depth. The ratio that works well for an 18-inch solar cooker is a depth of roughly 4 to 5 inches at the center, with the focal point sitting about 5 to 6 inches above the rim. Mark that focal point with a wire stand or a forked stick. That is where your pot goes. That is where the sun lands for the reflective surface. Mica is worth finding if you are anywhere near it. It occurs naturally in large flat sheets that cleave apart with a fingernail, slightly translucent, with a reflectivity that has been used industrially for electrical insulation and optically for windows before glass was widely available. In a solar concentrator, it performs extremely well because it is naturally smooth at the surface without any polishing required, and it conforms to curved surfaces without cracking the way glass or metal sometimes does. Look for it in road cuts, riverbanks, or any exposed granite formation. It appears as glittering flat flakes that catch the light. Indigenous cultures across North America, South Asia, and Mesoamerica all independently identified and used it for reflective purposes long before contact with European manufacturing. If you cannot find mica, foil pressed firmly and smoothly onto the clay surface works well. The critical thing is smoothness. Wrinkled foil scatters light rather than reflecting it coherently and cuts your efficiency dramatically. Take the time to press it flat. A smooth spoon dragged across the foil surface removes wrinkles effectively. One honest note that belongs here. A parabolic solar cooker requires direct sunlight and needs to be re-aimed every 20 to 30 minutes as the sun moves. It does not work under cloud cover, and it underperforms in haze or high humidity. Morning and late afternoon light arrives at an angle that reduces effective concentration compared to midday. Plan your cooking for the 2 to 3 hours either side of solar noon, and you will get consistent results. A pot with a dark exterior absorbs heat better than a bright one. A clay pot works well. A blackened metal vessel works better. For water pasteurization specifically, a clear glass or plastic bottle placed at the focal point heats faster than an opaque container because the light penetrates and heats the water directly, rather than conducting through the vessel wall. There is something I keep coming back to with this one. Archimedes died in 212 BCE when a Roman soldier killed him during the eventual fall of Syracuse, reportedly while he was drawing geometric figures in the sand, and refused to be interrupted. The man who understood parabolic geometry well enough to use the sun as a weapon was killed by the army he had held off for 2 years while working on a math problem in the dirt. His geometry survived him by over 2,000 years. It is still true. The curve still works. The sun still converges at the focal point exactly as he understood it would. A shape drawn in clay with a piece of string is still doing what that shape has always done. And it does not require a match, a gas line, a survival subscription box, or anything manufactured in the last 2,000 years to do it. Press the curve. Line it with something shiny. Point it at the sun. Find the focus. Put your water there. Walk away and come back to something sterile. Share this with someone who thinks self-sufficiency requires a credit card and a shipping address. It does not. It requires a shape. And now they know which one. If this ancient geometry has changed the way you look at the power of the sun, please subscribe and like the video. We are uncovering the history they tried to bury. Plant the seeds of the future. The next treasure will be revealed soon.